I'm so excited to be here. It's really great. And I wanted today to talk about the social connectivity of tall buildings. There's a new generation out there that are the new city dwellers, and they are really a socially connected generation. I believe that architecture has not caught up yet with this generation. They're the millennials. They invented social media and are in constant contact with their friends and colleagues. They prefer dense, diverse urban environments where social interaction happens just outside the front door. And our architecture in general has not addressed this generation. But it's not just the millennials, it's also just everyone is socially connected these days, and it's desired by everyone. So it's part of being human. Go figure, okay? So I'm Jeanne Gang. I founded Studio Gang Architects in 1997, and I've been working on tall buildings since about 2004. We've been using this human-centered approach to tall buildings, and even though, as we have learned through this conference so far, that tall buildings are more and more accepted, and they're appreciated for their iconic nature and their identity that they lend to cities, they still have some ways to go with the social connectivity. And so I'm talking about residential buildings today, tall residential buildings. Problems continue to persist with the buildings at ground level, through the accessibility and creating community with these buildings, as well as their environmental impact. So when we started working on tall buildings in 2004, we noticed that there were these kind of lines of ideas that were tying our approach together. So I'm only going to talk about 3 of those today, 3 strategies for making the building more socially connected. The first one is called exospatial, so the living on the outside of the building. The second one is called solar carving, which is making the building respond to the urban environment around it and not just the environment of the building itself. And the third one is called bridging, or in this diagram, straddling, the idea of making space at ground level for social connectivity. Probably most people know the Aqua Tower. That is a great example of what I call exospatial design. So we're exploring here the idea of outdoor living in its potential for its social dimensions on the outside of the building. And when we first designed this building, it was very rare to have balconies as high up as 82 stories, which this building is. It's a mixed-use building with a hotel at the ground level, and then rental apartments up till level 57, and then condominiums above that. So mixed use, and all of these 3 uses share common amenities. But the balcony, which is the exospatial part, is based on this idea that there could be terraces, almost like a landscape of terraces on the outside of the building that have different depths, different dimensions, and they relate to different parts of the city. So every floor is slightly different in this building. We were able to achieve this even with the construction with 3-day pour cycle. So it was completed in 2009, and it was probably lucky to be completed right before the downturn of the economy, but has been a huge success in Chicago and is a highly coveted place to live. The idea of the balconies really was, because the slabs are changing on every level, it's possible to see people with oblique views up and down the building and across the way. And they provide, some of the deepest terraces are 12 feet or 4 meters in depth, and they allow people to inhabit this outside space. These balconies, because they're different shapes, also confuse the wind, and so we were able to achieve this building with MKA engineers without a mass-tuned damper. But the idea is this connectivity exists on the outside face of the building, so people are able to associate out there. The second one is a building that we have currently under construction called City Hyde Park. And this building, again, uses the structure as its architectural, I guess, motif, but also a facilitator of social connections. The building has two faces. On the north face, which has views of the skyline in downtown, we use this alternating panel system for the columns, which allows us to have very large bay windows. Bay windows. And on the south side of the building, we use another system, which is a balcony concept, where the balconies come straight down to the ground, delivering the loads, the gravity loads to the ground, and tie back to the structure lightly, allowing us to have a thermal break in between the balconies and the building. So the environmental performance is improved beyond the Aqua Tower. So you can see here in the diagram the north side of the building and then the south side of the building, which has these playful, almost like a deck, a house of cards spiraling up the building so people can see each other and meet their neighbors. So we've created a threshold on the south side of the building, which is also has sun shading from these balconies and also an opportunity to meet each other. I should say that this is located in Hyde Park, south of Chicago, where the University of Chicago is located, and it also is a place where a lot of students and faculty will be living, and again, this new generation that desires social connectivity and community. Here you can see the model of the building and a rendering of how it will look on the south, and this is currently in construction. The balconies on the south, you can see there's units that are have different relationships to the interior, and on the north, a big bay with a column-free bay window. So this is how it's the rendering of how it's supposed to look in, when it's completed later this year. This new social connectivity also extends to the ground level, where people can create, shop and meet each other, and it creates a new social hub. During construction, you can see the structure going up the building on the north face, and on the side, again, the alternating panels. And this view looking up on the south side of the building, where the balcony stems are starting to take shape. And you can see the very dynamic relationships between the units. So here it is looking from afar. The balconies again, and then pre-handrails where you get these solar shading, but also this zone that it's a threshold on the outside face of the building. And we're really excited about this moving forward. Secondly, the second strategy I want to talk about is solar carving, which the idea is one that I think you find in New York, if you think about the 1916 zoning resolution, which was created to bring light and air down to the street. That's a form of solar carving. Also, Ralph Knowles, who was a USC professor, I've often looked at his work, where he suggests a kind of solar envelope for urban planning that would allow light and air to adjacent properties, almost like a policy proposition. For us, this idea is really about shaping the angles of the building and the facade, depending on where you are in the climate, to minimize and maximize solar benefit. So it could be, either self-shading or solar access. So with this project, which is recently started up again, called Solstice, we tilt the facade slightly on the south-facing facade to reduce solar heat gain, but allow solar heat gain in the winter in the Chicago climate. And so this was the first time that we tried to really shape the building based on the solar angles. The more recent project, which we just, I was telling Lynn, we just signed the permit documents and turned it in yesterday, for the solar carved tower in New York along the High Line. You can see here the modeling, the iterative modeling of the sun angles carving the shape of the building. So as I mentioned, in New York with the the zoning resolution that created the step-back skyscraper, if you look at our solar carved tower on the right-hand side, you will notice it's almost looks like the opposite of that, and that's curious given the location in New York. But I'm going to explain why, because of the specifics of the site. And here it is again. So the larger floor plates are actually at the top on this building. You can see in this view the High Line passing by beyond the building in its current location. And a view from the High Line itself with the carving faceted facade. So the step-back skyscraper is mostly smaller on top, but here, if we apply the solar envelope, the zoning envelope to our site, which is indicated in the red footprint, it would have a different kind of impact because the High Line is actually a park, a public park, but it's located in the center of the block. It's not on the street, it's not on the sidewalk, and so it actually inverts the whole idea of the zoning envelope in a certain way. So if we were to build our as-of-right building, here you can see kind of a short building, L-shaped, it would be crowding right up to the High Line, and also, I should say, blocking views from the High Line toward the Hudson River. And so because our site is literally right on the edge of the island of Manhattan, it has plenty of solar, the street has plenty of solar access already. We really need to think about carving the shape to benefit the High Line. So we argued for a variance to remove the red part of this diagram and put it up on top for a taller building, and then further to start carving away the shape to extend views from the High Line to bring light down to the space of the High Line Gardens. So this is the strategy, and we were going after more FAR, and we had strategies to carve it further and further, you know, based on the final approved FAR. So we were granted this variance because it made total sense to the city, and they agreed, and we are currently underway in planning. The final strategy for social connectivity in high-rises is a strategy I call bridging or straddling, spanning over or under features, urban features, including buildings and roads or axes, to make the urban connections for people on the ground. And you know, one of the biggest critiques, I think, of tall buildings is just that they are foreboding and at the ground level, and create large bases that people have to walk way around. Maybe not so much in New York, but in a lot of different contexts, this is happening. This building is located along this important axis that you can see it standing there in Chicago along Lakeshore Drive. And this is the axis. It's the 1 mile axis from the Field Museum going straight north. There's a clear view of this building, and it was an axis that was created by the presence of Lakeshore Drive. As well, the building relates to its site along the river. There's a wall of buildings, an urban wall of buildings along the Chicago River there. So it's taking part in both of these aspects of the site. This is the site of Lakeshore East, which is about a 26-acre development surrounding the Lakeshore East Park, the green area, a 6-acre park. And this is the same site where Aqua is located, the Aqua Tower I showed you earlier. So the orange area on the left is where the Aqua Tower is located, and all of the urban design pieces that were collected with that project. And on the north part, the small rectangle on the north is our new site with Magellan, and again with Magnuson Clemensic engineers. And this is the one that's located on the 1 mile axis. So the park was built first, and that was a very good amenity for the whole neighborhood, and has become a really beloved space, and they keep adding more commercial space and residential space around this park. And you can see in the plan here with north up, that the axis I was talking about zoomed in, and the Chicago River on the north edge. So there's a very wide roadway on the north of this site, and we need to navigate and cross over and under this roadway to connect people between the Lakeshore East Park and the Riverfront Walk. And so here you can see the park below, the Lakeshore East Park, and the diagram of the buildings adjacent to our new building. And this is, by the way, a building that is called the Wanda Vista Tower, and it is financed by the Chinese development firm called Wanda, and the tower will be called Vista. It's a hotel and residential tower located in Chicago. So this is a look at the elevated roadway that we have to pass, and so the idea of bridging under, over, and around to allow pedestrians to move through this space became a really important feature of the design strategy. The building consists of 3 stems, we call them stems, and you can see that the outer 2 stems are allowing the central stem to lift up and taking a lot of the structural load on the outer stems, so that the inner stem can be light, structurally light, and can be passed through on both the upper level of roadway and at the Riverwalk level. So these 3 stems are lifted, as you can see here in the zoom, and this is allowing this connectivity, this urban connection, and social dimension to the building. And this is what it looks like. So you can see very little structure coming down. The heavy lifting is done by the outer 2 stems, and this is on the upper level where there'll be sidewalks and drop off for the hotel and connection through to that 1 mile axis. Here it is in section. As you can see, it's a long walk on the lower level, about 600 feet to make that connection, which we are doing also with illuminated walkways and connectivity, and on the upper level with garden areas and illumination. This is a little model that we had to explain the issue to the city and to the client. And then just to mention the design overall of the building, it's based on this frustum geometry, which is a truncated pyramid. And this allows us to create difference within the building, both upward facing slopes and downward facing slopes toward the city. And then with the glass performance, we're needing higher performing glazing on the smaller footprints, and we can go more clear with the larger footprints, so that creates a kind of gradation. These are different studies of the building and iterations. This is a model we made in our office that represents the scale. It's about as tall as the room, but it gave us a very good sense of the in and out. We're creating more corners. So instead of 4 corners, the building that connects on every level has 8 corners for the units. And this shows a little bit more of the gradation of the color of the facade. And here you can see it along the river. And so most importantly, I think the base of this building is doing something that is quite rare in terms of tall building design, which is really creating a connection for people at its base. And this is an image of the building overall along the Chicago River. So it's a 1,288 foot tall, so a super tall tower with hotel and residential living within the city. So just to help if people are working on residential buildings in the room, I think the main points I want to make today is just these strategies that can be employed, the idea of exospatial design, balconies and outdoor spaces on the building that can provide the social connectivity, solar carving, which really looks at the space around the building and how the building is impacting that urban environment, and finally, bridging, which is the idea of lifting up and spanning over these axes, roads, and other impediments within the urban environment. So thank you very much.